Okay. Random number's good.
Yeah, just like Rainmaker, 74.2.
He wasn't random, he was calculating.
He was,
That's the coolest part. That's the coolest part about Rain Man. So we got Ernie and we got Bert. So I was intentionally vague with how I love that. Oh, that's cute, right between.
I know, it's right between, center.
I was very vague with how I proposed the question. Who's the better student? That puts it in your court as to how you define better. Because I think the discussion of how you're defining better is going to also help us define what we need to define as we go. So, initial ideas. Initial ideas. Wait, Chrissy.
Yeah.
Chrissy, okay, good.
Well, if I were to use my definition, like based off of what I calculated.
What'd you calculate, Chrissy?
Well, they have the same mean.
They do. What's their mean?
It's 81.
I want to call it X bar if it's okay with you guys. I'm assuming this is a small sample of what I could assess them on. We'll just go with the sample. 81? They got the same average. Kendra, you told me that too, didn't you? Yep, good. Chrissy, keep going, my friend.
And they are really similar in their median.
What are their medians?
It's 81 and 82.
Median is 81 for Ernie, 82 for Bert. Somebody asked me in the last class, are these out of 100? They can be if you want them to be. It's totally fine. Out of whatever you want them to be out of. So yeah, those are very similar, aren't they? Did you do anything else? Is there a mode?
No mode.
No mode. Too small. Small data sets very often don't have them. We can ignore the mode. Any other calculations you did, Chrissy?
No, but
Totally fine.
I just looked at like when you asked the question if it was better, I just said what was more consistent.
Ooh.
And so Ernie has a more consistent.
Ah, nod, yes. I like that word, consistency. Consistency. I'm seeing some nods, like we like the word consistency. Oh, good. Candace, go.
I like that he showed more growth in his scores because he went from showing at the beginning of whatever it was, 60, going to 100% if you put them in order.
Does this bother you at all?
Yeah.
Now, if you put them in order. Oh, you said if you order them 61, 68, 82, 94, 100.
I'm showing from a 61% all the way up to 100%.
I see what you're saying. So not in this order, but just in the order overall of his scores. Okay, Eric, help out if you don't mind. Go ahead. I love that, Candace. Thank you.
Yeah, I mean, I was just wondering if these are in chronological order on when they took the test.
They can be, they don't have to be.
Okay.
I mean, you could pair them off like this if you wanted to, or you could just treat them as 5 independent assessments.
Because under that assumption, if the middle test were, say, a midterm and the last one were a final, Bert shows a lot of growth.
Clever. Right. And this is so funny because I remember being in college classes like you guys are right now where my profs only gave a midterm and a final, and that was the only assessments we got.
Yeah.
Charlie Nastiger, if you guys have had Charlie in any classes before this, he remembers being an undergrad where the profs would hand back midterms with drop slips stapled to them if you did poorly on them. Because mathematically you couldn't pass the class based on this crappy grade you're just getting back. How's that for fun?
How's that for psychic?
How's that for total fun? Candace, go!
So another thing that I tried to do was
Thank you, Eric, for
drop
that.
off the
Love
top and the bottom
Oh!
numbers, and then average them again to see if that made a difference, to see if that would help us give a little bit of difference between the two.
Why would you think to lop off those values?
Just because they were the same for the average, so maybe that would give us a little bit of a difference.
So, what you did was a trimmed mean. I actually included a question about trimmed means on your exam in week 5.
Yeah, and I got into that, and so I had to figure out what a trimmed mean was.
Good! Which is part of the exam is I think you go Google it. Which is great in case you forget what a trimmed mean is. A trimmed mean is exactly what Candace just described. You lop off top and bottom data points.
And I just, only because I saw the 100% and I saw the 61%, and I was going, wow, that's a big difference in Bert's scores. So maybe to kind of level this out a little
We
bit.
did that. So if I lop off Ernie's top and bottom, which is 83 and 79, I think he's still at an 81, yeah?
Mm-hmm.
I'm guessing. And if I lop off Bert's 61 and 100, it's 176. So that's going to be close to 81, isn't it?
81.3.
81.3? Yeah, close. So even if we lop off the outliers, now I'm glad you brought this up, Candace. I had forgotten. The other class also invented 2 more measures. They said just drop the low scores. So in other words, re-average out of 4. So drop Ernie's 79 and drop Bert's, drop Ernie's 79 and drop Bert's 61. Now Bert wins. Because you took off one low outlier, but his high outlier is still pulling the average up. And then I said, well, yeah, why not cut the high score and leave the low score in? To which they said, why would you do that, mean old man? And I said, to prove the almost randomness of just picking one score to throw away. Because if you do that, now Ernie wins and Bert loses. Because he loses that right pull and now he's got a left pull pulling.
And that's why I try to even them out on both.
That's the point of a trim mean. Thank you. That's perfectly said. You even them out, so if there are outliers, you eliminate them evenly across both sides. Very, very good. So, there's no difference at all between them. That's the conclusion, right? Except the consistency that Tom measured. So it appears as though, in general, might not be enough to simply talk about the center of a data set, because you can have two data sets that are not at all similar that have the same centers. Pretty badass, huh? Doing this in 244 earlier with the kids today. We were trying to approximate the weight of an object from a sample. And depending on how many you sample, the shape of the distribution of the numbers changes. It has the same center, but the shape changes. The more you sample, the less the variability gets in the distribution, which is part of 243 towards the end. But all of that starts with the measure of consistency, or how to measure consistency. So I'm going to swing over here, and I really want to talk. I want to give it an overview and then get back into it, because I want you guys to make up a measure of consistency. So you got measures of center, and then you've got measures of consistency. Now, the word consistency, I wish it was used, because it's the most like logical word you guys come up with, term after term. This is one of the few things, the Bert and Ernie example is one of the few things I've used since like 1997. Almost everything else in my classes I change constantly. My original year of teaching, I started using Bert and Ernie, and for some reason, it seems to work for getting the idea across. And the first word anybody says is consistency. How many of you thought that word? Or inconsistent? Look at that! Modal. Love it. So I wish that statisticians used the word consistency. But they don't. They don't. They use the word variability, which is kind of like the opposite of consistency, right? They sometimes use the word dispersion, which, if you think about what dispersing stuff means spreading out. They sometimes use the word spread. So as a stat guy, I like variability, but we can just call it consistency if you want. Or the opposite of consistency, which I think some of you actually said, inconsistency. Okay. So, make up a number for me. If I had to pick one number, because this is the idea of statistics, it's being able to distill a data set down to a value we can then use. If you had to give Bert or Ernie a measure